learners, welcome back to the channel. Today in this tutorial, we will introduce you to two powerful and distinct concepts in Python: decorators for modifying functions or classes, and also asynchronous programming using async and await for efficient input-output bond operations. So, very first, let's learn what are decorators. In Python, a decorator is a design pattern that allows you to add new functionality to an existing function or class without modifying its structure. Without modifying the original structure, it adds the new functionality to your function or classes. So, decorators are essentially functions that take another function as an argument and it extends its behavior and also return the new modified function for you. So they are often used for logging, like recording functions call arguments and returns value, timing, measuring the execution time of functions, and also very much useful for authentication and authorization, checking user permission before executing a function, and also in caching, so storing results of expensive function calls to avoid recomputation, and also very useful in error handling, so adding retry logic or specific error management. So now you know decorators are like syntactic sugar, making your code cleaner and more readable for common patterns. So let's see how decorator works. A decorator is the function that wraps another function, right? So let's break down the structure and understand its mechanics. So a very simple decorator for logging I have written. So you can see very first I have defined the log function call. So this will define our decorator function, and it takes one argument which is func, which will be the function it's it is decorating. So right, see in down I have wrote another two function greet and add. So this will be the so as you see that before the function greet and also before the function add, I have added this @log function call to both before both of these functions. So it is decorating these two functions, greet and add. So very first this function log function call, what it is doing, it is decorating the another function greet and add. So it means this log function call, it is adding a new functionality and extending new thing to this existing function greet. Now inside this log function call, inside this function I have defined another function which is wrapper. So this is the inner function. So generally when we define, we call it as a wrapper function. So it's defined inside this log function call and will be the actual function. This is the actual function. So this will get called when greet or add this, when we will call this greet function and add function. So this automatically, this wrapper function will get called as we have added the decorator. As you can see, when I'm keeping the cursor here, it is also showing a decorator that logs when a function is called. Now inside this, as you see, I have taken two parameters, args and quarks. So these are used to accept any number of positional and keyword arguments. This is the positional, this is the keyword arguments, quarks. So ensuring that the wrapper can handle any function signature. Now next we are printing So this line, so print f calling function and then func dot name. So this is the argument I'm taking here, func, and then I'm printing this. So this line is part of the decorators added functionality. It will print a message before the original function is executed using this. To get the name of this decorated function, this one. So now next we have result. So here, mm, result is equal to func and then a position argument and the key, and then keyword arguments. So this line prints a message after the original function has finished its executing. And then next we are so sorry, this is the calling function, right? So this line is part of the decorators added functionality, right? It prints a message before the original function is called. And then this one, the result is equal to func. This is where the original function func with the parameter is actually called with its arguments, and it returned the value is stored in this result. And then next another print. So this line prints a message after the original function has finished its execution, and then we are returning the result, and also we are returning the wrapper. So this log function call, right? This log function call decorator returns the wrapper function when you use at the rate, this at the rate log function call. When we will use that, it will return it the wrapper function. So Python replaces the original greet, this greet or this add function with this wrapper function. Okay, so let me just clear all output so that you will understand it better. Okay, let me just run this for you. So see, till now I have just in this cell I have only defined the function. I'm not calling any function, that's why I didn't get any output. Now let's call the function. So what I'm calling greet, and then I have passed the name Alice, and then in the new line, what I want that I again I'm calling the add function, and with the parameter pass 10 and 5. So as you see, in both the function I have added the decorator. So first function greet, first it will call it like as I have written here, calling the function and then function name simply, and then in the after one, and here in between it will call the function, and at last it will again say finishing function and the function name. So that's why it has said calling function greet and then finished function greet and then hello Alice, and same with the calling function finished function a function name and then 15 10 plus 5. So this is what it does. Now let's learn decorator with arguments. So sometimes we need to pass arguments also to our decorator. So this requires an we can say this is an extra layer of nesting, you can say. So again I have defined a function repeat, and as you see this is the outmost function. It takes the decorator's argument num underscore times. It uh, doesn't take the function directly, it has another arguments, and then inside that I have defined another function, and this is your decorator repeat, and then I'm calling the function uh, and again inside that I have defined the wrapper function. So this decorator repeat, so this is an actual decorator function. It's defined inside a repeat and takes the function to be decorated, right? So that func here I have given and it will decorate this function. uh, this is the function that will be returned by this repeat, decorator repeat. Now in the define wrapper function, I have define a wrapper function as well. Same, it will take the positional arguments and then keyword arguments. And what I'm doing next is, so we can say this is the innermost wrapper function, identical in concept to example. Like it contains the logic that will be executed when the decorated function is called. So it uses num underscore times parameter from the outer scope repeat. See this here. Now I have this return wrapper. So this will return the wrapper function, and then we have return this decorator repeat. So the repeat function returns the this repeat function will return the decorator repeat function, this one. So that's what. And then next I'm calling the decorator at the rate repeat here with this name, and then I'm passing this num times is equal to 3, and then I have another function say hello, and I'm printing hello. In the next repeat I'm calling it 2 times, and then I'm simply I have defined another function print message, and then I print it. So let me just run this for you. And now I'm calling the say hello function, and in the new line I'm calling the another function print message. So let's see. So as you see, in first cell what I have given 3 times, and in the next one I have given 2 times. Just okay, see, repeating say hello 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 3 times, and then repeating print message. This is a repeated message. This is then again it is printing, and then it is saying finished repeating print message, as we have defined here. Repeating this, and then of this is the repeating, this will get called before the function get called, and then in between the function gets called, and in last it is saying finished repeating. So this is how the decorator function you can use. So when we define, as we have I have already told you that when you define this login, sign up, and then any error handling, we use decorator function a lot in web development to make our code cleaner and better. Now we will be learning about asynchronous programming. Okay, so asynchronous programming with async and await keyword. So traditional synchronous programming executes the task sequentially one by one. So if one task involves waiting, that means for a network request, a file read, or a database query, the entire program blocks until that task is completed. Now, what's the benefit of the asynchronous programming? So here comes asynchronous programming allows your program to perform other tasks while waiting for a long running operation. So we call it as input output bound operation to complete. It doesn't block the main execution thread, leading to more responsive and efficient applications, especially for tasks that involve a lot of waiting time. So in Python, asyncio is the library that provides the infrastructure for writing single-threaded concurrent code using coroutines. So it's like multiplexing input-output access over multiple network connection, running network clients and servers, and other related primitives. So the async and await keywords are used to define and control these coroutines. So the key concept here is coroutines. So it is special functions defined with async def. So generally when we define function, what we write? Def, and then we write the function name. But when you define the asynchronous functions, which is coroutines, what we will write? We will write the async keyword before the def. So they can pause their execution using await and resume it later. Next we have async def. So as I have told, it is used to define a coroutine function. When you call an async def function, it doesn't run immediately, it returns a coroutine object. Then we have await keyword. So it can only be used inside an async define function. It pauses the execution of the coroutine until the awaited got awaitable, like another coroutine, a future or a task completes. While the coroutine is paused, the async IO event loop can run other tasks as well. And then next we have some event loop. So it is the heart of async IO library. It manages and schedules coroutines, determining when to pause one and run another based on the await calls. So all these are the key concepts of async IO library. Now learn what is like basic async and await that we can use. Let's see how to use the async IO and await. So first you have to this import the async IO library. So as you see, I have simply imported the async IO library. Now I have also imported time. We will be using some time related parameters inside our code. Okay, so very first, as you see, I have defined a asynchronous function fetch data here. So how we will define this asynchronous function? We will write the async keyword, and then we'll write def, and then we'll write the function name, and then whatever parameter you want to provide, you provide it. So how we define the simple function in Python? In the same way we define as asynchronous function as well, but the difference is only we write the async keyword before the def. So I have written here a docstring as well to make you understand better. It simulates fetching data from a network or database, and it awaits for a specified delay. So this uh, as I have defined the fetch data function, and here it is taking one argument delay. Now the async keyword indicates that this function is a coroutine and capable of pausing its execution. Now in the, like, I'm not doing much thing, I'm simply printing it so that you will understand, okay, this function run and when it got run. So in the print line here, uh, I'm simply writing a message indicating that the data fetching process is starting, and it including the specified delay. That delay I'm taking as a argument, that I'm also that will get shown, that will also get shown. Now next I'm using the await. So this is the await keyword, and see how I'm using await, and then I'm using the library name async IO, and then from that library I'm calling this sleep function, and then inside that sleep I'm putting this delay parameter. So what is happening? This will pause this coroutine and it will allow other tasks to run. So this is the core of the asynchronous behavior. Here asyncio.sleep delay is an awaitable, meaning it's an operation that might take some time, and the await keyword pauses the execution of the fetch data, this function, a coroutine, at this point. And while fetch data is paused, the event loop is will be free to run other tasks, like another instance of fetch data, another thing of another part of fetch data program. After delay seconds, the event loop will resume the execution of this coroutine. And then I have added, once it will again like finish it, then I would like to print finish data fetched with the delay of the whatever the delay time it will show here. So this line will print a message indicating that the data fetching process has finished after the delay. And the last is here, uh, this one, this line returns a string as the result of the asynchronous operation. Now next we have async define main. So this is the asynchronous function that orchestrate other coroutines. So we can say this line defines the main asynchronous function named main, and also it will coordinate the execution of other coroutine. Now I'm given the start time variable, and it is asking the time. So from the time library it is calling the time function. So this line records the current time to measure how long the main function takes to run. And the next line is print. So we will print, simply will print the message indicating that the start of the main program execution. Next we are uh, create coroutines object. So till now we have only created the function. So now here I have even created the objects. So task 1 and task 2. So task 1, this creates a coroutine object. It doesn't run it yet. So this line creates a coroutine object by calling fetch data 2. It does not start the execution of fetch data yet. Think of it as a preparing a task to be run, and the next task 2, this is the fetch data 1. So this creates another coroutine object here. Similarly, this line creates another coroutine object by calling the fetch data 1. Now the thing is, next we are using this result where I will be using await and then asyncio library, and then I'm using from asyncio library the gather function, and it will take both the object task 1 and task 2. So what is happening here? So await task concurrently uh, using asyncio.gather, and this asyncio.gather runs coroutines concurrently and waits for all of them to complete. So this is where the concurrency happens, this line. So asyncio.gather takes multiple awaitable. In this case we have task 1 and task 2 coroutine objects. So and also schedule them to run concurrently on the event loop. The await keyword here means this await also I have used, right? So this await keyword here, it means that the main coroutine will pause its execution until both task 1 and task 2 have completed. The result of the awaitable are collected in a list in the order they are passed to gather. Okay. So now next line is print result and then end time and then print main program finished. So this line print result. So this line prints the list of results returned by the fetch data calls. Here, fetch data here. And next line is end time. So this line records the time after all tasks have completed. And the next line print, this line prints the total time taken for the main function to execute, formatted to 2 decimal places. Here I have given .2f, so formatted to 2 decimal places. Now in the last I'm calling this await main. So actually in different IDE, in different this I'm using here Jupyter Notebook. So the to call the main function I'm simply calling the main. So in Jupyter Notebook, instead of asyncio.run, you can directly await the main coroutine. This is because this Jupyter has built-in support for running async code in cells. But when you are writing the .py files, the simple Python file, then you might have to run the asyncio.run function. But here I am simply calling the await main. So this line is here, this line is the entry point for running the asynchronous code in a Jupyter Notebook, because it has already, Jupyter has already event loop, right? So we can simply await the top level main coroutine. Actually this tells the existing event loop to run the main coroutine until it completes, including this managing the awaitable task within main. This replaces the need for asyncio.run main, which would try to start a new event loop and cause the runtime error. So that's why asyncio.run cannot be called from a running event loop. So simply we have to call the await main. And then let me run this. So when I run this, see it has started. See, very first it has main program started. Then as I have called task 1 and task 2, task 1 has fetch data 2 and task 2 has fetch data 1. So that's why it is saying starting data fetch with delay of 2 seconds, then starting data fetch with delay of 1 second, and finish data delay of 1 second, and then finish data fetch with delay of 2 seconds. So result is data after 2 seconds, data after 1 second, and main program finished in 2.01 second, as I have formatted here till 2 decimal string. Okay, so now you see that when to use this async and await. So here also in this output you can see that total execution time is approximately only 2 seconds. The duration of the longest task is 2 plus 1, like this clearly demonstrate that fetch data 1 and fetch data 2 can run concurrently, not sequentially, one by one, right? If it would have been run by run, it would have taken the 3 seconds, but not here. It has only took 2 seconds to. So when to use async and await, well, we can say that for input output bound operation, tasks that spend most of their time waiting for external resources, and then also for web servers or clients, like build high concurrent web applications, for the long pooling or web sockets, like handling many simultaneous connections, then we can use this async and await. And also maybe any scenario where you want to do something else while waiting for an operation to complete, so at that time also you can use this asynchronous programming. So it's generally not beneficial for this CPU bound operation, tasks that spend most of their time performing calculations. But as Python's global interpreter lock GIL still limits true parallel execution of CPU bound task in a single process. So that's why for a CPU bound task, multiprocessing is usually a better choice. But for I input output bound, we should use the asynchronous programming. So we have learned about decorators, which provide a clean and powerful way to modify or enhance functions and methods without altering their core code, and promoting reusability and the separation of concern. And also asynchronous programming with async and await, which allows Python programs to handle input output bound tasks efficiently by enabling concurrent execution, and this leads to more responsive and scalable applications, especially in scenarios like involving network communication or other waiting operations. So both concepts are essentially like very much important tools in a modern Python developer's toolkit, enabling you to write more elegant, efficient, and robust code. I hope you like this session. If you have any doubt, write in the comment section. I will see you in the next video. Thanks for watching.